Today we're taking a look at scientific notation. All right, so to start with, scientific notation, super important in science. So what kind of numbers do you typically see used when you're talking about scientific notation? What would we use it for? What's the point? Say that loud for me, Sarah. Really, really big numbers and really, really small numbers. So when you're talking about, like the distance from here to the moon, or something like that, if you're talking about the size of the nucleus of an atom, I don't know, that's probably pretty small, right? Y'all know better than I do because you're in chemistry, right? Most of you? All of you. I think all of you are in chemistry. Yeah, so scientific notation is used for really, really big or really, really small numbers. So just having a little bit of practice with this is super applicable since all of you are in those classes. So a little bit to write down here. So the basic form for scientific notation is a times 10 to the n. That shouldn't say x, my bad. This should say a. The a value is between 1 and 10. Again, I'm going to mark this out and we're going to rewrite it. It should say 1 less than or equal to a less than 10. That's what it should say there. And the n value is an integer. So it can be positive or it can be negative. Technically, it could even be 0, although that's not a very useful value in this particular application. So you're usually done with positives or negatives. And what we'd like to be able to do is move in and out of scientific notation when we need to. That's the goal. Can you take something scientific notation and understand it in a standard numeral? Can you take something in a standard numeral that would be a really, really big number, a really, really small number, like Sarah said, and put it in scientific notation so it's more condensed and easier to write? Okay? So the first one we're going to look at is taking our standard really, really big or really, really small numbers and turning them into scientific notation. Now, both directions when we move these, we're moving decimal points. So we're going to move the decimal point to a location that will create a value between 1 and 10. And we count the number of times our decimal place moved. Did it move 5 times? Did it move 3 times? Left, right, that kind of stuff. And that value will be your exponent. If that value came from a large number, right, you had a big number to start with, then the exponent's going to be positive. And if it came from a very small number to start with, the exponent's negative. So small and big are kind of relative terms, so I've given you kind of a reference point. Small means smaller than 1, big means bigger than 10. Okay? So yes, I recognize that 20 is not a very big number, but by this argument, the way we're looking at it, 20 would be considered a big number. Okay? Now, when you've seen scientific notation in the past, you might have had somebody explain it to you having to do with whether you move things left or right. To move the decimal left or do them as the decimal right. I never explain it that way because if you explain it that direction, then it switches when you're going into scientific notation versus going into standard notation. So I don't want to think about right and left. If I always think about the fact that positive exponents mean numbers are big and negative exponent means numbers are small, it works both directions, which is a lot more friendly with trying to keep up with it. Okay? Okay, does everybody have all the details written down thus far? Okay, we're going to do a couple of examples. Just as a reference point, let's start by you telling me. The first one on there, is this a big number or a small number?
Big.
It's big. I'm pretty sure all of you would like to have that much money in your bank account. How about that small? How about the second one? That number would be a small number. Okay? So it's good. Taking a look at the number 298000, where could I place a decimal point so that I create a number that's between 1 and 10? Where could I put a decimal point? Between the 2 and the 9. So if I put a decimal point there and I created the number 2.98, is that number between 1 and 10? Yes. Okay. So that's going to be the A value in that basic form we just wrote down. It's always going to be times 10, that part's going to stay the same, to a power. And that power will be how many locations the decimal point actually moved. Now, as the number was originally written, it doesn't sort of appear to have a decimal point in it. But where is the decimal point actually located? At the end. Our decimal point's actually right here. That's where it was. So how many moves did it take to get from where I put the black decimal point to the point when I put the red decimal point? Trey says 5. He's right. So if I were to count 1, 2, 3, 4, and 5, that's what I would get. So I have an exponent of 5. Is the exponent supposed to be positive or negative? Positive. Why? Because it's a big number. Okay? All right, looking at the next example, I need a new location for my decimal point. Where will my decimal point now be? Okay, by the 3? Like between the 3 and the 8. Okay, good. Just clarifying. Good. After the 3 or between the 3 and the 8. Yeah. So if I put the decimal point here, I have 3.8. Is that number between 1 and 10? Yes, it is. And then this will be times 10 to a power. Now I have to figure out what power. How many locations did my decimal point move? 4. 1, 2, 3, 4. Will it be a positive 4 or a negative 4?
Negative.
It'll be negative. Why? Because it's a small number. Any questions on those two? Because we're about to flip the script. Go the other way. Yeah. Okay, we're going to flip it. Now we're going to start in scientific notation and find the corresponding standard numeral. So when we do this, we are going to move the decimal point the number of places indicated by the exponent. So if the exponent says 5, the decimal moves 5. If the exponent says 6, the decimal moves 6. If the exponent is positive, the number will be larger, right? It's going to be a big number when I'm done. If the exponent is negative, the number will be a small number when I'm done. Positive exponents, big numbers. Negative exponents, small numbers. Okay, ready to try a couple? Yeah? Okay. So, I'm going to start kind of like I did with you a minute ago. I'd like for you to look at the value that you're given and tell me if I'm going to have a big number or a small number. How about number 1? Small. Why? Because the exponent's negative 5. And the second one? It's big. Because the exponent is 3. So I'm going to give myself some space here. I'm starting out with 3.2. And technically, you know, you can put zeros all over the place. We sort of ignore them when they're not helpful. We put them there when we need them, but there's just lots of zeros here. right? Before and after the value I'm given. This 5 tells me I'm supposed to move the decimal point 5 places. And the question then becomes, do I move it left or right? And the answer is based on where we expect our value to end up. We expect our number to be small when I'm done. So if I'm going to do a small number, which direction is that decimal going to move? It's going to move left. And it's going to move 5 places because it's the power 5. So here's 1, 2, 3, 4, 5. So I will have a decimal point, 4 zeros, and then 3, 2. The number's small, right? Very small. All right, on my next one, and notice, I didn't say it, but notice I didn't write any of these extra zeros at the end. There's no need to write them if they're not needed, okay? My next value is 6.24. And again, there's lots of zeros, both before and after what I've got. How many locations or places will my decimal point move? 3. And my answer is supposed to be big when I'm done. So will my decimal point move to the right or to the left? Right. It will move right because that will make the number bigger. So here's 3 places, which means I didn't need all my zeros that I wrote down. That's fine. So I end up with the number 6,240. All right, so now when you're actually working with really big numbers or really small numbers, it's a lot easier to work in scientific notation. So what do I mean by that? Well, I mean if I were multiplying numbers together or dividing them, it's going to be easier if they're in scientific notation than they're expanded. For example, if I had the number I don't know what number that is, but it's an 8 followed by 11 zeros, okay? Just bear with me. And I wanted to multiply that by a 6 with 14 zeros. That's a lot of zeros, right? This isn't especially friendly. Even though it's just 6 and 8 that I have that are non-zero, it's still a huge number. Agreed? So instead, it would be much easier to work with the numbers in this form. That's where I just got those numbers. That one is 8 with all those zeros. And then the second one is the 6 with all those zeros. Because then I just work with the 6 and the 8. So Preston asking me, you're already asking me about my exponents, so I'm going to pause on that one for just a second, but you're right. First I want to deal with the 8 and the 6. What is 8 times 6? 48. And then the nice thing is that we just talked about properties of exponents. You guys just did a whole bunch of problems on them. And you know that if you're multiplying 2 values with the same base, which you are here, base 10, what can you do to those exponents? You can add them together. So what is my power on my 10 at this point? It's a 27. Now, we're not quite done with this problem. We did the first part, which was the calculate the following. But there's a second part that says write my answer in scientific notation. What about this value that I have right now makes it not that, it's not in scientific notation yet? What's wrong with it? 48's more than 10, right? I'm supposed to have a number that's between 1 and 10, and 48 is not. But 4.8 would be, right? It would. The question simply is, what do I do about the rest of the value to keep it, the same thing? Well, here's what we do. Since I had a number that was big, right, bigger than 10, this exponent gets bigger. So what do you think the 27 is going to become? 28. It's going to get 1 bigger because I moved the decimal value 1 place. All right, these are not quite as friendly simply because they're not integers, but I can do the same thing down here. Grab your calculator if you'd like. Multiply for me 1.2 times 9.5. What do you get? What'd you get, Lauren? 11.4. Do you have others getting 11.4? Okay, great. Now let's deal with the powers of 10. This will be times 10 to what power? 10. 10 to the 10. Now, one could argue that this number is not especially big, but by my definition of big, it's still big. Because it's bigger than 10, right? So this is a big number. What number would I need to change 11.4 into to be a number between 1 and 10? 1.14. Right? And then what will happen to the exponent on my 10? It's going to go up 1 because it was a big number to start with. It will now be 11.
So depending on how many places you move the decimal, you use that.
Yeah, like if our answer had somehow ended up at like 624, let's say, times 10 squared, like let's say it ended up here, and you had to move the decimal point 2 places to get to here, then yes, you'd add 2 to your exponent up here, and it would be a 10 to the 4th.
Okay.
Yep, good observation. All right, so I don't know about you, but this kind of multiplication is way better than the long 8s and 6s that I just wrote down a minute ago. That's just messy. It's really cumbersome. And not only is it true for multiplication, it's also true for division. So let's take a look at the division facts that we have right here on this one, okay? The division, not always, but often will end up giving us values that are already in scientific notation, okay? So if I pair them up, much like I just did on the last screen, I can do 8 divided by 2. What do I get? I get 4. And this will be times 10 to a power. So you guys asked some good questions about your homework last time about these powers. I have a 4 here and I have a -6 here. What do I have to do with those two values since it's division that we've started with? You'll subtract. So right now it's 4 and then it's minus -6. So what is 4 minus -6? I actually get a 10. And better than the problems I just did before, it's actually in scientific notation, this particular one, when I'm done. Okay, 4 is not, it's not as pretty because it's 9 and 2. But what is 9 divided by 2? Please don't put it in your calculator. You guys know it. It's 4.5, right? Times 10 to what power? 5. Preston, how'd you get 5?
8 minus 3.
Right. 8 minus 3. And this number is in scientific notation, right? Yeah. Any questions on that?